We're streaming on LinkedIn, sending data now to YouTube, and we are also on Facebook. So, welcome.
Good to be here. Good morning.
Yeah, let's get our intro going. Welcome to Blueprint Tour. We are outside at an undisclosed location. Thank you. Please. Autographs at the end. All right. Here we are. We are outside an undisclosed confidential location. However, today we are going to be talking about HVAC mini splits and how what they can do, what they cannot do, the good and the bad and the ugly. Very interesting topic. Of course, as always, we welcome anybody to call in. We put the link in the comments in LinkedIn. I'll go ahead and add that to Facebook as well.
Yeah.
In the YouTube stream. So you can click that and we'll bring you in as a guest. And we could discuss if you have personal opinions or questions. Let's say you are looking at a renovation or having comfort issues and wonder if a mini split is the right fit for you. Come ask us and we'll walk you through what the good and the bad are, the code implications, comfort issues, and we'll dig into that as we go.
You got your phone for the call-in?
Yeah, the phone's right here.
So you've got the link in the LinkedIn for the restream. Are you going to put your number in there?
Oh, yeah, I could. Maybe on LinkedIn.
Or can they call in through Restream?
They can call in through Restream. They click the link.
Okay.
And bring them in on Restream. Cool. So, if you click the link, we can bring you as a guest into the conversation. So I'll go ahead and head to Facebook, add the link in the comments. It's in the description as well. So let us know if you see that. All right, I'm commenting as Kenny Schultz. Join here to ask questions.
Doesn't have to be an HVAC question. That's going to be the topic, but jump in, and if you have a question about anything else, we will be glad to chat about it.
Yeah, and we're also be in Chicago next week talking to people in the HVAC industry, actually the ASHRAE thing. So it's kind of a precursor to that. The official tour, not next week, sorry, that's the week after next. The official tour starts next week where we'll be going to visit Urban Core. We'll be talking to Dotson Development, a few other cool people. Stuart Evans Construction at his podcast studio. And so keep an eye out for those. We'll post the dates here soon. We're actually, hopefully, Matt Savinsky reached out. He's a pretty cool guy. I've always liked to talk to him. I think he'd have a lot to offer. He's on the GC side of things. So let me add this one link. Oh, man, the description.
That was the name from yesterday.
Yeah. So we are still getting used to things, and that's why right now we're testing our gear, our equipment, streaming, so that when this becomes official.
Right there next to clip. To the right, I think. 3 dots.
Oh, yeah.
Oh, never mind.
All right, I can't comment on this on YouTube. Oh, well.
We can change the name after.
Yeah, now I'm trying to comment to I'll add it to the description. Nope, I can't. About. All right. Well, and anyhow, sorry for the YouTube folks that don't have the link. It's we know most of the people anyway on the Facebook and the LinkedIn environment actually knows personally. YouTube, we haven't really even put that channel out.
Yeah.
It's just we've been getting subscribers though. We're have almost 10,000 views of just the content that we've been releasing out there. So it seems there's definitely an interest in the industry to have somebody be talking about things. And our particular focus in the tour will be coordination. We've talked about it a lot with folks. Every person that I talk to has a different perspective on what they think it should be and who should be responsible for it. And I think that'd be a interesting conversation to evolve over time. Engineers and designers have a specific responsibility for it. However, the perspective of the installers, their perspective on coordination of what the designer side should be is much different than what the designer themselves feel they should be responsible for,
Mm-hmm.
and vice versa. So
Mm-hmm.
trying to open that up and more or less find common ground, and more importantly for the people in buying and investing in real estate to understand that that's a chasm in the industry. But today we're here to talk mini splits, what you can do, what you can't do, legally or practically speaking.
And it seems like the difference between what's legal and what's practical is pretty big, or it can be big, at least in the HVAC world.
Mm-hmm.
What do you say? The code doesn't care if you're comfortable, just cares that things don't freeze and people can breathe with fresh air.
Yeah, that's true.
So you could be doing something that's code compliant, and a lot of times that's what we get asked to do is on the engineering side is just do what the code wants, the code minimum, which works for a lot of things, electrical, plumbing, even mechanical in some instances. But there are some cases where just give me the code minimum is going to leave you pretty uncomfortable in your own space for the years to come, which is not good.
Yeah, yeah. Another one-liner we use is you can be as comfortable as you can afford an HVAC, and it's not really anybody's fault there. I mean, it's not even the owner's fault. I mean, HVAC is an expensive thing to invest in.
Mm-hmm.
So the code doesn't really dictate that you must be comfortable. Really, at the end of the day, if we're not talking hazardous materials or any other special uses like operating rooms, generally speaking, the code cares about ventilating the space, which means providing outside air to the inside of the building.
Mm-hmm.
And we're outside today, sun's beating down, and it was freezing cold this morning. So that's the air you have to bring out from the inside. If it was colder, say 10 degrees, in Virginia, we designed to about 20 degrees, then that volume of air literally is coming from that outside at 20 degrees, or worse in the summer at 90 degrees, 93 degrees, with a lot of moisture in the air. And so when you bring that in, that's where the problem starts. So when you think about mini splits, you have to think to yourself, well, what are my ventilation requirements? Do I have a high demand for ventilation or not?
Yeah, and on the topic of solar gains, Kenny, I mean, we've got all these layers on because it was cold, and it's still about 40 degrees outside and the wind was blowing. But now that the wind has slowed down, I'm getting kind of hot sitting here with the sun beating on us right now.
Yeah. Yeah, I always tell people that's the reason your cat lays in the sun of your house, because the sun is a different beast. It's the type of heat that comes through the window is two parts. It's the thermal or the convective heat that's transferring through the mass of the window and contributing to heat into the space. But then there's the radiation heat that radiates directly through, and no amount of air blowing across that radiation coming in will cool that down. So if it hits you directly, it's going to cause a warming effect the way we are being warmed up now.
Mm-hmm.
That warming effect can't be really dealt with in a meaningful manner with HVAC. And so a lot of people will ask us, did you account for solar gains?
Mm-hmm.
Well, the answer is yes, technically, but you still feel the heat no matter how much air is blowing on you. And really, the building science as a whole is the solution. You need to have your windows treated. Have solar shades. We always encourage that because in a hot day and it's sunny and the sun is coming straight through that window, it's going to be uncomfortable. There's no way to get around that. So yeah.
Here's a stupid question, Kenny, as somebody who's not a mechanical engineer. Would extra tonnage fix that, or would that lead to short cycling and other issues?
Yeah. It's the extra tonnage it could help. It could help, but you'll still feel, if you have a huge wall of all this sun beating down on us, no matter how much air is just blowing out, you're going to still feel the effect of that warmth.
Mm-hmm.
And like to your point, then all that extra tonnage will just cause it to kick off.
Mm-hmm.
And that leads into a completely different issue of you now can't remove moisture. The only way to remove moisture from your space is to keep the tonnage going. Now, in the summertime, when the moisture is prevalent and you want the air conditioner running, if you oversize it, then that thing will just dump all that cold air and then stop.
Mm-hmm.
So you no longer feel the effect. You might temporarily feel cool, but if you're also ventilating at the same time, dumping all that fresh air in, now you're introducing moisture that can't be dealt with.
Mm-hmm. Not to mention, it'll fix an issue in one place, but create an issue in another place depending on how it's zoned. Because if I'm sitting next to the window, and I got the window seat, and you don't, you could be one row over a desk for me, but the sun isn't shining on you. Now you're going to be freezing cold.
Yeah, it's a weird world. HVAC is maybe it's just our perspective as HVAC engineers, but there's two things that always happen when things go wrong. It's like the HVAC engineer messed up, I'm uncomfortable, And that could be true. And it often can be true. But the problem is the entire building envelope is a huge contributor to your comfort. The thermal envelope itself is one of the major parts of our calculations. So if we are assuming you're going to be putting insulation on a roof, for example, and that never happens, or we can assume based on the level of renovation that you'll be insulating it from the code's going to require it, but somehow you get around it, well, then now your roof doesn't have any insulation. And so, that outside, there's so many things that affect comfort. Or like Carter was saying, I'm next to him and we feel different levels of comfort. And then there's this personal interpretation of what comfortable is. From office to office, somebody might feel cold where the other person's comfortable. So again, I always go back to, you can be as comfortable as you can afford, literally. Like if you have to have a value engineered HVAC system, then you can expect there to be limited levels of comfort. And the mini split is an often value engineering solution that can work. It's actually a pretty decent solution in many cases. There's something called a multi-zone system, and that or multi-split rather. So you can have, everybody has seen the little wall-mounted mini splits, or they come in the cassette unit that just sits in a ceiling grid or something. Those are nice, and so those can get into low tonnages of like 3/4 ton, 1 ton, and they can connect to a single outdoor unit. We spec that a lot. It's a very nice way to give like small zone comfort to people. However, they're very poor at providing ventilation to the space, and so it's a good solution if you have maybe a DOAS providing ventilation elsewhere, or it can deal with some level of fresh air. But moisture removal is a completely different topic. They're not very good at that, and that's the key when you're dealing with high ventilation loads.
So when I hear split system, I think residential, right? And I know that's not the only application for a split system, especially something like a mini split. But what are some commercial applications where a split system makes sense? What are some of the downfalls? You brought up ventilation for certain commercial spaces. That'll come up, I'm sure, more than others. But what are some of the pros and cons for split systems in a non-residential application?
Yeah, it honestly, I think it all comes down to the major deciding factor being how much fresh air do you need ultimately. But yeah, split systems are a great solution for commercial, especially office light commercial stuff. I mean, you have an office, it's almost invariably going to be used unless you have a roof where you can just do a package system. In our market of the light commercial market, that's kind of the permit zip market where we are. So we see a lot of small offices. There's conference rooms, things like that. And in fact, a conference room is a perfect use case for a mini split. Because it's a dedicated zone, and not a wall-mounted mini split, but a ceiling cassette, or what we call a ducted mini split, which is basically a pancake fan. And then you can basically duct it and bring in fresh air. The downside of that is, the pros is that you get a dedicated zone for the conference room. And if you don't do that, then most HVAC contractors and engineers may agree that if you don't give a conference room a dedicated zone, somebody's going to call you in the summer and tell you that you screwed up the install, because it's just not going to be comfortable. You pack 10 people into this space, and suddenly your internal gains go through the roof. And in order to deal with that, you have to change the temperature to make them comfortable, which makes all the offices that it may also be connected to extremely cold, and they're not comfortable. And now they suddenly are going to say that the contractor or the engineer both messed up the design, when the reality is it was a budget function. You can be as comfortable as you can afford. It always goes back to that. Like, if you can't afford the extra 20 grand or 15 grand or whatever it is for that conference room dedicated system, then you're going to have to deal with the comfort. And our responsibility as engineers and installers is to really walk through with people that, the slimmer the budget, the less likely you're going to be comfortable.
Mm-hmm. Yeah, especially when it comes to zoning for HVAC, because correct me if I'm wrong, but I don't think there's many code requirements in terms of how it needs to get zoned. I mean, that's more or less a personal preference.
Correct. There are some energy code requirements about multi-zone systems like VAV systems and all that, but generally, again, the code doesn't care if you're comfortable. The only thing the code does say is that you have to be minimally, you have to heat the space where people are. You have to bring it in. Virginia, I think it's 65 degrees, and then the ICC codes are at 70 degrees. So you do have to stop people from freezing to death inside of spaces. But in terms of the cooling set points, I mean, basically it just says use the ASHRAE standards, or if it's residential, there's another like manual J, I think it's what it's called, method of load calcs, and all of that is mostly just saying how much is going to come in from the thermal envelope, what are the internal gains, and just some basic rules. They're very similar in their approach. The residential is a lot more simplified. But yeah, that code, then the energy code says that you have to have a dead band in your design, or that you can't design below like 75 degrees, I think, for cooling. And a lot of people don't know that. Your cooling set point is 75. Your HVAC engineers are designing to 75 during the cooling, not 72 or whatever your thermostat is at home.
68.
Yeah, 68. Yeah, exactly, right?
Nice, comfortable sleeping temperature.
Yeah, so keep that in mind when you say you're uncomfortable or the HVAC engineer made a mistake. So we try to let people know early in the design process. Do you know that when we design, it's for 75 degrees set point, which means on a hot day, you can only get to 75 with the math. Like in theory, 75 is the best you're going to get on the peak day. And the peak day varies depending on where you are in the country or the world.
And that's what y'all call design, like design day.
Yeah, design day. Yeah, the ASHRAE design day. Now, trace calculations, we won't get into it today, but that's a very technical thing. They do a heat balance method, which is like a whole energy modeling method to do the calc, but it's called a CLTD. The TD standing for temperature difference. I actually forget what the CL is, but basically, it says
Comfort level? That's just a complete guess.
Yeah, I don't know. The CLTD method basically is say, hey, 1% of the year in the summer, it's going to be like 93 degrees in Virginia, and this humidity outside of the building. And then now inside, what is your set point? You tell it, hey, I want 75 for cooling. It'll say, okay, based on that temperature difference between the outside and inside, and some general assumptions about heat transfer through these walls, how you set them up, the windows and the insulation, all that, then you can expect this much cooling capacity requirement. And then you take and you calculate all the people inside. So when you go back to mini splits, you know, the applications that they work best on are applications with low latent loads. Latent load is the moisture content, a certain amount of energy that goes into removing moisture, phase changing the state of the air. That moisture has to be removed. That condensation, the reason we have condensate pans, has to be removed. Now, mini splits are limited in their latent capacity. It's a sensible heat ratio, what they call it, is like the capacity of moisture removal compared to the capacity of temperature comfort removal. And in standard systems, you're probably around 70%, which is not suitable for an assembly hall. Like you know, you're not going to be fine putting mini splits everywhere for assembly unless you have a DOAS to put with it, which is treating the outside air for ventilation as a completely separate piece of equipment where you can then have control over the internal moisture through that process.
See, all the stuff you just said kind of ties into, I was reading a Mike Holt forum, and Charlie B, shout out to Charlie B, said that the code shouldn't be a design minimum standard. It's a legal minimum standard, right? And that's especially important in the HVAC world because a lot of the things that you just said don't come directly from the code. They come from the consulting and the knowledge that you have, you know, so we try to remind ourselves, we try to remind folks, if you're hiring an engineer, you're hiring a consulting engineer. It's like you really want to get the most bang for your buck. Listen to them. You know, sometimes we can go off in our crazy engineering world and over-engineer things, but just telling your engineer to do code minimum is almost guaranteed to leave you unhappy. You'll get your permits and it'll be legal, but you're not going to be comfortable. So why not listen to what they're saying? It's going to cost more, right? Of course, it's going to cost more for the equipment that they're saying, but that's the consulting part of what we do and try to help, you know, kind of guide folks on what we know will work best.
Yeah, for sure. Well, I think it's important for engineers and installers to try to understand the business itself, what's happening, just to kind of get a feel for what does the operations look like. This comes into play with restaurants and kitchens and chefs that basically are designing a menu, which then results in what they need to have to prepare that menu, which leads to the ultimate design of the hood. Well, that's directly connected to the HVAC budget. We talk about this all the time, and it's just going down to that and understanding that that's how that business is planning. The restaurant saying, all right, chef, can you deal with less hood? As much as half of that hood may be the difference between you actually getting this idea off the ground based on how much funding you have and not. And mini splits, same thing. Like, don't go into this thinking a mini split's going to work, because often it won't. A good solution for mini split would be like, hey, all right, I value engineered. I got some equipment that I think will work, but the tonnage I forced, not forced, I suggested very strongly to the engineer to change their design, right, from 25 tons down to 15 or something crazy, right? Or we took a DOAS out. So often what I'll tell people, all right, I'll first of all be comfortable with that as long as you acknowledge in writing that it's against my engineering judgment, but it's not illegal. Now, a mini splits come into play in that situation where, like, we just had this conversation with the church. We're like, all right, we'll try this just so that you don't have to spend the money today. And day two, once this is up and running, if it's a comfort issue, throw a mini split in there. You just need a little bit of extra capacity. The ventilation's already taken care of. You know, it was just a zoning thing, basically. And it was this little area that was, a wall was being added. And it's just like the zone is kind of like a conference room, basically. And technically it could work, but if enough people get in there, it might be uncomfortable. And then boom, day two, if it really is causing enough pain, put a couple ceiling mounted cassettes in there. Or if you got jip on the ceiling and that's not a good idea, you could put a couple wall mounted if you don't care to see them. Architects are not the ones that love seeing those things. But you know, that's another use case for mini split is, all right, I'm going to value engineer, quote unquote, or what we like to say, feature reduction, because I can't simply make this work. I have to be open. The cash flow has to start. And then day two, if some area of this entire project is uncomfortable, I'm going to throw a couple mini splits at it. Circuit Social in Richmond, that's exactly what happened. You know, he ended up just throwing a couple mini splits in it. They had the ventilation they needed, all this good stuff. And then when it got open, it was a little hot, so he put a few on the wall. And then, you know, he described to me that it just basically worked. Everything got comfortable. So day two. Yeah, so dealing with the wind, whoever it is that's tuning in, sorry about the wind, but don't forget, we are encouraging you to call in. There's a link in the comments on Facebook and on LinkedIn. Click that, and you'll be able to join the conversation. If you have thoughts or if you think what we say is crazy, please join. Hop in. Ask us questions. If you're a business owner and you're curious about what to do with something that's making you uncomfortable, maybe mini split will help. We'll help walk you through that. It's a great solution in a lot of cases where you just don't have the ability to tear the ceiling down and duct everything, put a couple things on the wall. You know.
Yeah, and if you're not able to catch this live and you're watching it after the fact, we're going to be doing a lot of these. You know, reach out, shoot us a message on LinkedIn, email, whatever. You know, and say, hey, I want to get in for an episode, or hey, next time you guys go live, like, hey, here's a topic that I want to talk about, whether it's HVAC, plumbing, electrical, anything, really.
Yeah. Or if you want us to swing by your construction site and talk about mini splits or DOAS, when to use a DOAS, I mean, anything, man, or electrical service upgrades, coordinating with the utility, what's that going to take? Water.
A lot, usually. Takes a lot.
Yeah, it takes a lot of money.
A lot of money, a lot of time.
How much money is this going to cost? Value engineering questions, you know, all those kind of things. We have done so many projects, hundreds and hundreds and hundreds of projects. It's crazy. And so we just want to talk about them during these live sessions that are just internal to us and give everybody a chance to come in and chat, you know, or if, you know, we've designed something and you got a headache with it, shoot, roast us live. We're fine with that too. Anything that could be useful to the community of construction with what we know is what we're after. And that's what these conversations are all about. Yeah. And plus we get to sit outside and drink coffee and, you know, talk about some HVAC.
Yeah, the seat's definitely not still wet that I'm sitting on, so it's okay.
Yeah, last night it was storming, raining, wind blowing everything off everywhere, and then this dried just in time to make it almost dry enough to sit on.
Somewhat seatable.
Yeah. Sittable. So, mini splits. What are other mini splits? Can also be part of VRF, variable refrigerant. You know, if you guys have done variable refrigerant, it's projects. It's kind of the same thing. What we call the indoor units can be either connected to a dedicated outdoor unit for like a heat pump, or you can have what I talked about earlier, a multi-split, where there's a couple of these indoor units connected to that single 4 or 5 ton outdoor unit. That's good for like commercial. Or if you have a large hotel or something, you can then take one massive outdoor unit, get that up to 30, 40 tons, and get a couple of those, and then connect that to, you know, 10s and 20s, 30s of the indoor units. And that's another use case. It's kind of like a mini split. And if if you're confused, there's also this thing called a ductless mini split, which is ridiculous to say or sorry, ducted mini split and a ductless mini split, because it's not ridiculous. Sorry, it's more that people think about mini split as that wall mounted thing, and that's not the only kind of mini split you can do. There's ducted mini splits. It's basically an air handler, just like a regular split system for in your house. You know, split system, if you're unfamiliar with that, is just saying it's split, meaning there's an outdoor unit split apart from the indoor unit, which is different than a package system where that outdoor unit and indoor unit where the fan is are all together as a single thing. So when we say split system, we're talking about when those two components are split apart. Mini split is kind of like a miniature version of those splits, intended to get down to like 3/4 tons, 1 ton, whereas a traditional split, kind of the smallest size, is 2 tons or so.
Mm-hmm.
But yeah, so ducted mini splits are, you know, now you can get yourself a 3/4 ton ducted air handler for a small zone. I mean, that's a very good use case. If you just want a dedicated small zone, conference room is a great example of that. And they can deal with part load conditions better than your traditional air handlers as well, which is cool. They can't remove moisture, so assembly use probably not a good idea, you know, unless you have a dedicated outdoor air system with it when you have assembly.
Sounds like something would be good for like an addition on a house or a building.
Yeah.
An additional room. And
Yeah.
if you didn't want to extend dock work and maybe tap out the capacity of the existing system serving the rest of the building, you could have its own. I'm thinking like a sunroom, you know, in a house.
Yep.
Perfect for like a little ductless mini split on the wall. But even if you got a commercial space, an addition, a couple hundred square feet, maybe,
Yeah.
you know, multi-split, mini split. Seems like a good application for that.
Yeah. Or, you know, buyer's remorse sets in and you wish you'd listened to Permit Zip all along to not go with combining your conference room in with your offices. You buy them, you know, they're I don't know, $7,500 to $10,000 so installed. I mean, contractors will have to tell you, but I would guess somewhere between 10 and 20 grand.
Mm-hmm.
It ain't cheap. You know, it's a lot easier to just go ahead and do it during construction, but it's a great, easy solution for a lot of little mini zone issues. You know, when you don't need more ventilation, you just need a little bit of comfort addressed, or you just need a little extra cooling in a space, like in Circuit Social.
This is kind of related to mini split. Tell me about the pros and cons between, you know, folks. A lot of times in the meetings and during the VE process, they might not want to spend the extra money on a completely separate unit, but they want to get those like zone dampers, right? Maybe a thermostat in the room that's tied to a damper that opens and closes to give the space a little more air or a little less air, depending on what that room wants. What are some of the pros and cons of doing something like that? Because to me, if I don't know any better, that sounds like a perfect solution.
Yeah, it is a good solution, sorta. You know, that's basically variable air volume system, and that's kind of I suppose in that world, what you're doing is adding a zone damper to vary the air volume into that area. But the main supply fan is constant volume. So in order to deal with the fact that you're increasing and reducing the pressure through the system for that little damper that opens and closes, you got to install a little zone bypass damper. And that just bypasses back to the return to adjust the pressure in the system to keep it, you know, constant, so that the remainder of the space still gets the air that it wants. The downsides, I mean, and it's a good way to kind of manage demand between two different areas. The downside being if one is asking for heating, one's asking for cooling, then that could be problematic. Or, you know, the fact that you're kind of wasting energy by sending air that's been cooled right back to the return, and then that decreases the return air temp. Could cause some issues where there's like a part load or no load condition in one of the zones. So they're usually encouraged to limit the total amount that you're putting on that kind of system, especially for a DX coil or something. You know, I forget the best practice. There's a little manual for this, I think, for designing little zone damper systems. I will say we haven't had great success with them, especially if it's a large kind of peak load like a conference room. It can work, it sort of works, but it can be problematic. And also there's a lack of commissioning, I think, in the light commercial. So what happens is you don't have anybody actually testing, commissioning that whole system to make sure it actually operates as intended. and then you end up with a bunch of finger pointing there. Whereas a full VAV system with a central air handler with variable speed VFD on the primary motor and actual VAV boxes, that gets real commissioning every single time, so you can make sure the system actually works. So if you have issues, you know how to solve it. Light commercial zone damper system, something goes wrong, it's really hard to get evidence of did it get installed right, because there's no real commissioning agent, like third party, to make sure, and then it becomes a finger pointing. So we don't like to design those for those reasons.
And it might be a little bit of extra money to get a separate, independent, dedicated zone, like a mini split, but you're saying it's worth it because any contractor worth their salt could probably install it with their eyes closed, you know,
Yeah.
and it's much easier to test, commission. It's completely separate from the, you know, the other system. It sounds like it'd work a whole lot better.
Yeah. You know, you can maybe, let's say you have a CEO corner suite or whatever, and you can put a little VAV dampers in to help them get a little more control. But, you know, that only goes so far, but it can help, you know, if they need a little extra cooling because they have some extra people in there, 1 or 2 extra people, and they can ask for it with a little price, I think, makes the integral VAV dampers for low pressure systems. So those can be in the really small part load the really small zones like an office, that may be a good application. But once you get to where you might have 10 people, 5 people in a room, like a conference room, your load can peak and spike pretty high. Then those zone dampers aren't as effective. It's probably better to just put a little mini split there.
Right. That's where you can be as comfortable as you can afford comes in.
Yep. Yeah, and see, the problem is, and I can totally sympathize with it. Let's say you go with the zone damper method. You're still spending more money to try to get that to work. And so you're still spending money, and rightfully may feel frustrated if it doesn't feel comfortable and it's still causing issues. But the reality is you needed to have spent more money than that. And so that's why we discourage from some of these kinds of ideas, because it's like really it's kind of a waste of money. It's just not even worth the improvement. You might as well just deal with it on the other side as just being a no zone damper sometimes.
Kind of like those phase dimmers you got that hummed. You still spent money on the dimmers, and they did dim your lights, but it was just a bad experience. You should have spent a couple more bucks to get something a little nicer.
Yeah, what Carter's talking about is I bought a little dimmer for my office, and I didn't know this until I installed it. But if you don't connect, I guess a phase dimmer doesn't have a neutral connection, or somehow the way it works in the electronics is it creates a lot of noise. And so when you do that kind of dimming, phase dimming, then you'll hear a hum physically in your office, in your space, and it's loud enough to be a nuisance. And it drove me crazy. And I did it because it was like a $10 dimmer versus the $100 dimmer, and I didn't need to pull, and I didn't have the neutral there. So I was like, well, let me go with the cheap option. Whereas, like, let's say if I was doing this with an electrician, they might have charged me, I don't know, $100 to put the cheap dimmer in, and then $750 to do maybe $1,000 to do the expensive one, because I had to pull new wire for that. And so buyers are more set in. I couldn't even use the dimming. Yeah, I might have got it for $100 instead of $1,000, but it was just not even worth $100 because I never dimmed the light at all. It was so loud, the hum. And so if dimming was a requirement that I wanted, then I should have gone for the 1,000. And I ended up installing it myself, and it was beautiful, Alexa enabled, everything.
Nice.
It was awesome. I had to pull a new neutral there to make it work, though. We'll have to do that with your one of your circuits here.
Yeah. I mean, that's the thing. You'll spend money to get something that kind of works. I mean, it worked, but it wasn't really a great experience. That's kind of a parallel to the zone damper solution. It will work, but it's not going to be something that you're happy with, which sucks because you spent money to get it fixed. But the reality is you just had to spend a little bit more money, and a lot of times that comes back on us in a weird way, you know. So we try to talk people through what that means and say, look, this solution A here is going to cost you money, and you're going to be unhappy with it, right? So let's just bite the bullet now, spend the extra bit of money, and you know, you'll have something that's comfortable and it works.
Yep. Yeah, 100%. And so mini splits is that world. And if you know, as an engineer, our responsibility is to try to help you understand, will that solve the problem or not? Will it be a waste of money or not? Zone damper, Carter brought up, is a solution. And shout out to Josh Kreider. He's Howell's Heating and Air. Like, they are an incredible contractor. He's one of the smartest. engineers, and I've seen his designs. He's got the gift, right? He knows exactly when a zone tamper system can work and how to lay it out. And that's the problem is you kind of need to have experience with it and know what it can and can't do and its limitations in order to suggest it. So if your engineer is being asked to do it, like have they worked with them before? You know, we've had them put in, and I'll tell you one of the use cases that doesn't really work all that well is the conference room scenario. It's we've had better results. Let me put it this way: statistically speaking, fewer, almost zero, actually no callbacks on systems that were given a dedicated mini split for conference room. You know, whereas zone dampers or constant volume with no zone dampers, we get, you know, people will give us callbacks and say the engineering's messed up. We're uncomfortable in the conference room, and the answer, it's not that the engineering's messed up. That's not true. It's just that you didn't purchase the right equipment because there were budget limitations, and that's really hard to communicate with people up front. Because, you know, rightfully so. You still spent, let's say, 40 grand on the system. It's still frustrating that it's somehow not working. But
and it could be installed and designed perfectly, and it still won't work. You know, as good as an independent zone, because it's just a function of the system and what it is.
Yep. So sometimes, you know, there's ways you can work around that architecture. Again, we go back to the building design. The architecture, instead of having it be a completely enclosed conference room, have it be one that's open to an open office so that the air can be mixing and sharing that load and part load. That was part of the solution for the church we were talking about earlier. You know, instead, we had talked about just removing this wall instead of separating these two zones. Just let it be a big open area. Does the wall, does it need to be there? Because if it's not, then you have technically the cooling you need. Essentially what you have is, imagine one space where a group of people are going to be in it, and they're either going to be in place A or B, that whole group of people. So, I mean, you know, if you were to put a wall in between a system that has the capacity to deal with the people, then, you know, you kind of have half the capacity on A or B. And it's like, you can kind of make it work maybe with a zone damper. That's actually probably not a bad use case, but it would require big surgery on the ductwork. You could put a zone damper to basically say, well, when there's a call over here, then put most of the air where the people are. But still, not having the wall is the easiest solution, the cheapest solution. Adding the wall, now suddenly the real best solution is to get rid of all the HVAC and just redesign it for that new use. But comfortable as you can afford, you don't want to mess with that. It's like, all right, fine. Why don't you just go ahead and, like, as long as we can prove from the code perspective we can get you the ventilation for each space that you need, then it's not illegal to be uncomfortable. Go ahead and give it a shot. And if you find that you need the comfort later on, mini split's the solution. Just put a couple things on the wall until you're comfortable.
One by one, until you're comfortable.
Yeah. I mean, that's also a great thing about multi-splits. You can buy a multi-split and have multiple indoor units connected to a single outdoor unit. So you can maybe get a little 2-ton multi-split and put a little 3/4-ton indoor unit on it, and then and if it needs more, then to the same multi-split, put another 3/4 ton onto it. Of course, all of this is stuff you would want to talk to your engineers about, and more importantly, the actual installer and the vendor and the rep, because each of these systems kind of has their own specific requirements. So, but yeah, that's a lot of the art of consulting in this world, and it goes down to communicating to the buyer what they can and what they can't do with it. But I think often they just see it as a solution. A mini split just seems like a solution, so they jump on it. Like, cool, why don't we just add a couple mini splits here?
Yeah.
You hear that? Somebody's out on these fields.
Yeah. What else besides conference rooms? I mean, I think on one of the earlier episodes we talked about kitchens and how maybe that's not the best solution for a kitchen because of the hood source capture.
Yeah, we've been tempted to add ceiling mounted cassettes in the actual kitchen where there's a Type 1 hood. Ceiling mounted cassette's a good solution for kitchens if you don't have a Type 1 hood or like that. You know, it's easy. There's no ductwork to mess with, all that. But when you have a Type 1 hood where source capture of the grease-laden vapor is essential and required by code, the code actually says that you can't design a system that will mess up that ability to capture the grease-laden vapor
Sounds
of the
important.
cooking. Yeah, it seems pretty
Yeah,
important
yeah.
because you don't want people to die
Breathe
from
in
all
grease.
that. Yeah. And
Huffing grease.
yeah. And so if you can imagine you have a ceiling cassette that's in your ceiling like this, the air will discharge from it along the ceiling in this manner, which means it's just headed straight. Sorry for this crazy ass wind gale. The air from that thing is headed straight for the hood, which means it's going to mess up the like factory tested listed capture, the effectiveness of the source capture for that. And so ceiling mounted mini splits are not good for that reason. Even wall mounted split mini splits are not good in kitchens. The same exact thing. They're on the wall. Maybe sounds like a good idea, but suddenly you're blowing air straight into that hood. Whereas the ideal design for a kitchen is what we call laminar flow diffusers. You know, Captive Air makes them, or we've seen it used as a sock duct from a budget area, and that's like allows the air to come in into the kitchen and just diffuse slowly with low air velocities and just fall. If it's cooling, the air is just going to fall. It's heavier than the hotter air and just make its way, wash it over the folks in there cooking, and then eventually make its way through the hood. But you don't want to shoot it straight at the hood. And that's the problem with the mini splits in a kitchen.
Yeah.
In the occupied zones where the people are, I mean, they could work if you need some extra cooling capacity. As long as you get your ventilation. You know, there's a cheat for ventilation too, couple cheats. One is windows and doors. If the occupied area has enough openings, and again, this is specific to the code of your area, so, you know, always consult with your engineer in the local codes. But generally speaking, if you have enough openable doors, windows, garage doors, then you can get what's called natural ventilation. And if you can do that, then you get a lot more flexibility. But let's assume you have the ventilation you need. It's being brought in, everything's fine, but you're still having comfort issues, and they're not related to moisture content. Then mini split, throw them on the walls.
Mm-hmm.
And even if it is related to moisture content, I guess you're just going to have a cold, damp area. And that's the mini splits can't fix the dampness problem in a space. They can only fix what you feel on your skin. It's called sensible load, is that part that you actually can feel. But you've all been in a place that's technically in your mind comfortable. You just can't put your finger on it. Why does it feel so muggy or so damp or so weird? You know, and that's moisture. It's 70-degree high humidity, 70% humidity is just going to feel absolutely insane. So
It's like that Virginia weather,
yeah.
you know.
Yeah, I mean, in Virginia, in the East Coast, southern states where you have moisture, that's crazy. You know, Texas, South Texas, I would guess they have a lot of humidity too. But once you get into the dry areas of like Arizona, Texas, then it's a different problem. And you actually, you know, that's a good. Okay, mini splits have a higher level of versatility. Did we just lose our signal?
Got darker.
Yeah, let me check on that. In the drier climates. So you can probably get a lot more bang for your buck in the drier climates. I'll be right back, 1 sec.
Seems like it's coming back.
Yeah, I just scared it into working.
Yeah.
Woo!
A little windy. Get back over here. I have to tie you down. Are you, it's still really windy.
We are out here, and
At
it
least
is
it's
windy as
blowing
hell.
this way, not this way, because
Yeah.
thing's a little weak one way. A
Yeah.
lot of good stuff we're talking about, though. I mean, guys, this is something that, of course, if you have a project with us, feel free to jump on. But I mean, this is free engineering time right now. You know, if you've got a project you're looking at, you're thinking about, I think you'd be hard pressed to get an engineer on the phone and be able to ask them these questions about some sort of contract or a week or two lead time. We're not going to be doing these all day. We've still got actual work to do, but you know, whenever we're on here live streaming, or if you catch this after it's live, shoot us a message. You know, I mean, this is like free engineering hour. Of course, it's not, you know, official guidance, and a lot of things to consider there. And we do have an actual contract and you know, permit drawings that we can do for you. But if you just want a quick kind of idea, bounce an idea off of somebody that knows what they're talking about, jump on here, let us know, you know.
We got 15 more minutes for calls. Anybody that wants to come in. In the meantime, I'm actually gonna let's see. Can I do this? I wonder if I can share. We can go over price. You know, we have an instant quote to show you. Let's see, window.
Benoit just texted me on Slack and said, "Is it cold there?" Yes, it's cold, Benoit. I don't know if you're watching, but the wind is kicking, and it is a little bit colder than where you are, sir. I wish we were over there with you.
Yeah, it is. It is a cold day today. I almost chickened out from doing this. Ask Carter, like, do you have an extra jacket I could wear?
Hey, I got my long johns on under my sleeve, man.
Yeah, man, the wind's blowing. You can hear it. But, you know, we're just trying to find ways to do some interesting settings. That's why when we do this, it'll be actually called a tour. We'll be in different offices.
Mm-hmm.
We'll be on construction sites. We're going to just be doing, exploring as much of the world as we can in construction and just bringing it to y'all and talking to as many different people from different backgrounds about different topics. So if you have ideas or you're curious, you want us to reach out to somebody, I'll call whoever and see if we can get them to be a guest. You know, if there's somebody you want us to talk to, let us know.
Stop by your office. We can stop by. You guys can swing by. Anybody that wants to be on the show, just come on. We got a couple extra mics and plenty of seats, and we can have a good conversation.
Yeah. So, all right. So you can see our website right now, and what we have. Interesting. This is cool. I wanted to just show y'all a little bit about this. Of course, what we're doing are these live sessions. This will let you call in, ask questions about engineering. We'll talk through everything that we know and help answer questions about, especially if you're out there trying to get a lease on something, you know, like, do you have, it's the clouds. That's what's causing the, you know, if you're, hey, I want to put this church in this new conference, in this new office space, or I'm about to lease this, I want to make a donut shop or whatever, you know, just ask us questions. We've done so many projects, and
Hundreds.
you know, we've also run this business together. So if you have questions about it, we'll have the perspective from the business side and the cash flow and the day one, day two. That's what we always like to talk and integrate into our engineering consulting is, all right, well, can you live with this today?
Yeah.
And then this tomorrow, because at the end of the day, this HVAC that you're buying, let's say it's supposed to last for 15 years. Like, do you really want to have that 15 years designed wrong?
Yeah.
It's a problem.
Yeah.
It's one of the worst things that, of course, we're the HVAC. I mean, I'm an HVAC engineer, so one of the worst things that could be value engineered, because I'm thinking, well, 15 years. Do you really want to regret that decision for every single year for 15 years, man? Man, I wish I had listened to Permit Zip about this and spent the extra 40 grand here and paid that 40 grand into my business on day two. We call it day two. You know, like, let the cash flow start. Make sure you've really got what you need in terms of comfort, and not only just comfort. Don't forget, HVAC is also about protecting your investment. If you allow the moisture to just wrench its way into your investment, it's going to create mold. It's going to create problems. Trust me.
Yeah. Hey, you're talking about, you know, non-ideal conditions for a building. You know, electrical, obviously, as long as everything's safe. You're talking maybe a light switch that's in kind of an annoying spot. It's not really a big deal with everything Alexa. I mean, my whole house is hooked up that way, you know, so that's something you can deal with. But, or there's easy solutions to help kind of mitigate how annoying it is. But something like your HVAC being designed poorly, you know, or it's, you know, is not an easy thing to kind of fix and move on. You're talking, you know, like you said, 15 years of discomfort. And,
you know, it's I have to correct Mr. Huddleston here on saying designed poorly, because a lot of times it's not designed poorly. It's designed to a budget, and that budget is the problem, not necessarily the design. And that's a realistic scenario. A lot of people, they just can't do it. And I understand it. As a business, you're just limited. You can only do what you got to do, and you got to get open, you know?
Yeah.
But it's easy to say that the designer or the installer messed up. And, you know, we're here to defend both the contractor and the engineer in that situation. It's just, that's why we prohibit in our consulting the phrase value engineering. There's really no such thing. It's a unicorn. Do what?
Feature reduction.
Yeah, feature reduction. Actually, Jeff Contro has another word for it. I forget what it was, but he's on the same train. He sells the HVAC equipment at Shelley Williams, and they're great. And he's a PE and a super smart guy. I'll be with him in Chicago next week. And, yeah, he had another. I'll have to remember what it was. Ask him about it. Because anybody who installs HVAC, designs HVAC, and sells HVAC knows there's no such thing as value engineering.
Yeah.
You know.
Yeah.
The GCs will say it because they're, that's part of the thing. We just talked to Kurt Yards. They genuine value from a good contractor is to help understand what can be taken out of the construction budget. Lighting packages is often on the table.
Yep.
But HVAC, when it comes up for the value engineering thing, it's always on the chopping block, and then we always are just like, man, really though? What about the wall that's made of plants? Can you just not have that wall?
Or the skylight that's making the mechanical worse.
Exactly. What about just a lot of times building a lot of times building envelope is a legitimate place to go, because if you insulate the roof, we actually went through this with Urban Core on the Spur project. They were trying to figure out would it be worth it to insulate, because it was a historic building and it wasn't required by code. And we did a quick study and said, well, if you want to buy 50 tons less worth of HVAC on this building, then go ahead and add insulation. And that was a no-brainer.
Yeah.
So value engineering is a big building science topic, I think, if you're going to go that direction.
It's a multivariate equation. The thermal envelope, the building size, the building type, the material, everything, plays into. And I mean, that's how y'all make your decisions for the most part. Obviously localities and local codes and all that, but after that, it's going to be, what is the building? Is it brick? Is it stick? Is it sheetrock? Is it ACT? Like, what are the parts and pieces of the building? Is one wall completely glazing? Is it not? Is it insulated? What type of insulation? Where is the insulation? In the roof, in the walls, in the floor? Is there a crawl space? I mean, there's so many things that you guys consider in your load calcs, and you guys consider it, but you still can't get it perfect, and it's a lot of, the HVAC engineer messed this up, or the ductwork doesn't fit, and it's like, well, let's go back to how we made these decisions, right? Like, what about the decision to make the building have 11-foot ceilings and sheetrock ceilings?
Yeah, and glass.
And glass everywhere.
10-foot glass, the entire wall system. Mm-hmm. Whenever I see that, I always say, put shades. Yeah. Solar shades, rated for actual solar shades, not just shades, something that can block that radiation. And yeah, that's a huge one. But you may not know this about HVAC. Load calcs are a literal guess, man. I mean, load calculations for the HVAC industry, no engineer will actually tell you this, but it's a guess. It's a straight up guess. I mean, yeah, it's an educated
but a guess
based on historic weather data that's always changing. And
just like the wind right now.
Yeah, exactly. Exactly. Look at how much the sun and the wind has changed just during this conversation. That's like Mother Nature we're talking about. We are trying to guess what Mother Nature may do over the next 15 years for you and see, can this system handle it? Not only that, we're also making assumptions about the envelope often because we don't have full great data, or, we're assuming that certain things will be done to the envelope that aren't always done in real practice. In small projects, they may not insulate those walls that are supposed to be insulated or should be, or we're told it will be insulated and they end up not being insulated, or a skylight gets added we didn't know about and the equipment's already been purchased, or the programming changes, or somebody wasn't completely truthful about how the space is going to be used and they're expecting twice as many people.
Yeah.
Or maybe they're not following their occupant schedule. I mean, there's 1,000 things, way more than 1,000 things that come into play that make that educated guess be something that's not going to work. At the end of the day, if you're asking for HVAC to be reduced, tonnage to be reduced, be ready for your comfort to suffer. Just period. And also, let's say you have 20 tons and you say, I'm fine with that, but I don't want this variable compressor or whatever feature that could deal with part load conditions. Because remember, when we design for that 1% day for cooling.
Yeah.
And if it's not that 1% day and you got 40% of that assumed load, your system's not going to do a great job. It's going to overcool that. So you need to be able to stage the compression for the cooling down. This is, on the topic of mini splits, one of the great ways that mini splits can work. They're great with dealing with some part load conditions. Mm-hmm. So that's actually a good way to, maybe you have a constant volume rooftop unit that's 10 tons and you want to put another 5 tons of mini splits to kind of help you give some pseudo staging, then there's some use case there. Mm-hmm. As long as you don't have ventilation loads to deal with. If you can get them from natural ventilation, let's say, instead, or other hacks that can be done with bipolar ionizers, then yeah, mini splits can be used to kind of augment your load condition. Yeah. But you have to be told, as the buyer, day 2, if you really want to make your HVAC day 2, we always recommend buying HVAC day 1 the right way. But if you can't, then all right. As long as you acknowledge, especially specifically in writing to us engineers,
Yeah.
that you're okay with it being dealt on day 2, then we'll work with you there. Yeah. But we always say in this industry, no good deed goes unpunished. So if we're trying to help you and work with you on your budget, then in our experience, invariably, if something goes wrong, then we're still like held to be blamed. So don't be offended or put off when your engineer or designer asks you to just state it in writing that you understand the risks, because it's just our experience that people will come back and still be upset, because the reality is you spent the money still.
Yeah.
It's like maybe it wasn't 80 grand, but you still spent 20 grand. I mean, sorry, you still spent 60 grand. So you saved 20 grand, but you got to remember that 20 grand is removing huge amount of features for you to save that 20 grand. And you're still going to feel emotionally frustrated when it doesn't do what you want to do,
Yeah, that term
Sure.
ventilation comes up a lot. We can get back to that. Actually, you want to pull up the instant quote and just kind of walk some folks through that. I think there's one.
Yeah, so we got the instant
one
quote.
eyeball there.
Here.
One viewer maybe. Welcome.
If you're interested in ever knowing how much things cost, we do have an instant quote on our website. So we'll look at that real quick. So let's say you have a project name, we'll call it Mini Split. And this is designed to help you understand how much the MEP engineering would be. And let's put this at our office, 1212 West Silver Hills. Last pass is protecting me. Don't even know what that means. All right. It's all right. My last pass is jumping in. Dang it. Hold on. I don't want this. I want it to go away. All right, well, you don't need to do an address. That's one reason for me to talk about it. If you don't want, if this is a project that maybe is sensitive and you don't want to disclose to us the address, you don't have to. It helps us understand it, because then we can help you consult through that. But if you don't want to disclose, you could just give us a name, something that helps you understand a mini split project, right? And then you can decide, do I want mechanical, electrical, and or plumbing, and tell us the square footage. Make your best guess here, on what might be applicable. But let's say you got a 3,000 square foot office and you're just trying to do a renovation. You can give us a quick description if you'd like. Put your name and your email and phone number, which is also optional. There you go. So it'll let you know the range to expect. We're always tweaking these numbers, but a full MEMP set could be on the cheap side, $8,300 up to $27,000, depending on your needs. Some people have high needs for construction supervision and all that other stuff. This can get expensive very quickly. But if you just need a permit to get it knocked out, remember, that $8,300 might sound expensive to you, but understand that this is also 3 completely individual construction sets: one for plumbing, one for mechanical, and one for electrical. But if you're interested in just saying, all right, well, what if I just needed an electrical? Then you can just simply change this and recalculate. And there you go. Wait. That should be, it's the same price. I'll have to talk to our software team on why that is. But in any case, this app is constant. We have a software team constantly in development of this app, and it's going to get even stronger and more powerful. You'll be able to customize your proposals with more features in the future. But you can also send yourself. It has emailed me a proposal, and it'll be in the median price if you want to authorize it. But that way you can also see our standard terms and conditions for these. So don't be shy. Go to permazip.com/instant quote and go ahead and get an understanding of how much the engineering might cost you, and we can officially, on record, consult on your mini split questions or whatever other ventilation needs you might have. And it is working. So that got updated, 7,300. If I add plumbing to the scope, 8,300. Okay, yeah.
Yeah, and we're about to wrap up here, but on another episode, we could talk about why this range would be so high, because that would be a question that I would have, Kenny, as somebody that's maybe interested in working with us. That's a pretty big range. What does it look like to be at the lower end of that range? What does it look like to be at the higher end of that range? What is needed for me in my situation?
Yeah. We're losing some sunlight, so got to change the camera setting. But yeah, that's a good question, Carter, and we are going to tighten that range in for folks over time. but suffice it to say that for now, it'll give you an idea of where you might stand, but we're certainly going to be, there we go, tweaking in that range, making it a tighter range. Right now it's kind of broad based on the old calculations, but we're refining our algorithm and improving it, and looks like we fell out of focus, but just keep it up, keep using it. If you have feedback or ideas for the Instant Quote app, just go ahead and let us know, and we'll add that to the development team's agenda.
Yeah, and that's kind of just get an idea, guys. Like always, we're here to reach out to if you have a question. Maybe your project is a little bit different. That's just kind of to get an idea of what the price is, and once we get it dialed in, it'll be more accurate. But yeah, I mean, you can make a project as simple or as complex as you want. Some folks are maybe trade contractors, like a Ben Matthews at Metro. Shout out to Ben, that knows exactly what he wants to do for a design build situation. He gives us exactly the design, and of course we do our due diligence, and we go through the supervision and we get it wrapped up for him. But there's a lot less consulting that needs to go into something like that than maybe a developer who this is maybe his second development or something, and he's not used to getting permits, and we're more than happy to help kind of walk them through that. It's just a little bit more effort. Sometimes it's back and forth, or maybe have an architect that's highly detailed that wants all of our drawings to be coordinated. That extra fee kind of represents that. So we try to give a range. It's not a one-size-fits-all approach, which I think most people would appreciate, because if you're the person that wants to have that detailed set, you don't want to be told halfway through that you're out of budget. But on the opposite, if you're that person that just wants something quick and dirty that'll work, that's legal, but you don't need a lot of hand holding or consulting or back and forth, you surely don't want to be overpaying for that. So that's kind of what we're trying to get at with the range.
Yep, absolutely. And we'll show more of that on future episodes on how to use it. For now, we are going to cue up our outro music and thank you. All right. Thank you for tuning in. We are we'll see y'all next time. Next time we need to get some callers.
Yeah.
We're gonna be texting a few of you in advance to make sure you call in. We need some interaction, and we want people to be interacting with us as we do this, and make it a little more interesting for the listeners. So don't be strangers. Call in. Otherwise, we'll see you next time. My camera's about to blow over right now because the wind is insane. It's been great. Thanks for letting us hang out outside. We'll see y'all next time.
See y'all.